All right, we're going to go through another practice quiz with some, fun problems about quadratics and exponential growth and all that fun stuff. So we're going to start with some problems about quadratics. If a quadratic function has a vertex at 3, -4, the y-intercept at y equals 2, find a formula for the function. So they give me a vertex, which means that I probably want to use vertex form of a parabola or of a quadratic. So what is that? That is given by p of x equals ax minus h squared plus k, where hk is my vertex. And a is just some constant in front of, stuff. That tells us kind of how steep the parabola is, and we'll have a way to find that. So the first thing we should do is we should take this information about the vertex and plug it in. So we'll have p of x equals a times x minus 3 squared minus 4. And now I need to find out what a is. And what I can do to find out what a is I can use the fact that the y-intercept is y equals 2. Well, what's the y-intercept? The y-intercept is what happens when x equals 0. So when x equals 0, I should get 2 as an output. So let's go ahead and write that as an equation. Go away. 0 minus 3 squared minus 4. Doing a little bit of simplification, we get 2 equals 9a minus 4. Maybe we add 4 to both sides, we get 6 equals 9a. And divide both sides by 9, we get a equals 2/3. So we use the vertex, we use the y-intercept, we found this a value, and we finally get that our answer should be p of x equals 2/3 x minus 3 squared minus 4. And yeah, if you plug in 0 here, you'll get 2/3 times 2/3 times 9 is 6, and then 6 minus 4 is 2. So that all works out. Okay. Next, we want to convert a quadratic to vertex form. And you might have seen something called completing the square, which is kind of the official way to do this, but we're going to do this a little bit of a quicker way, which is just by using the formula for the vertex. So what's the vertex? The vertex has an x coordinate. I'm going to call it h because that's what we have in our vertex form up there. H is going to equal negative b over 2a. And I don't have a fancy formula for k, but basically for k, we just plug in this vertex for x, and then we see what our corresponding y coordinate is going to be. So let's start with that. So h equals negative b over 2a. That's going to be negative 20 over 2 times 2. That's negative 20 over 4, which equals negative 5. So I have h, and k is just going to be, I'm just going to plug in negative 5 for x and see what I get. So we get 2 times negative 5 squared plus 20 times negative 5 plus 10. Well, that's going to equal 2 times 25 plus negative 100 plus 10. So that's 50 minus 100 plus 10. That's 50, negative 50, negative 40. So when I put that all together, so I found my h, I found my k. What's my a? My a is just this number in front of x. That just stays. So I'm going to go ahead and put those all together. I'm once again going to use vertex form. My a was 2. We have x minus negative 5. That's the same as plus 5. And then we subtract 40. And that seems to make sense. If I do this, that turns into x squared plus 10x plus 25, so 2x squared plus 20x plus 50, and I subtract 40, so that all works out. So that's my answer. And yes, what I was doing there is I was foiling this in my head, and I was saying, hey, when I foil this, do I get back to this? And the answer is yes. So we did that. Let's go on to some other problems. All right. In this one, we want to find the x and y intercepts. So the first thing I'm going to do is, well, we can start with the y-intercept. The y-intercept, it's this. That's the y-intercept. It's what happens when you plug in x equals 0, but when you plug in 0, those first two terms go away. So the y-intercept is going to be negative 12. If we want to write that as an ordered pair, which is probably a good thing to do, we should write that as 0, negative 12. For the x-intercepts, we're going to try to factor this, and if we can't factor that, then we can always pull out the quadratic formula. In this case, we should be able to factor. So my two numbers are 2 and negative 12. I multiply those together to get negative 24. And then my b number, that's 5. So I want to find two numbers that multiply to negative 24 and add to 5. Two that work are 8 and negative 3. If I hadn't been able to come up with those numbers, again, I would have just used the quadratic formula and I would have got the same answer. So I'm going to use those numbers to split up my middle term. 2x squared plus 8x. While I'm doing this, why am I factoring? The reason why I'm factoring is because I want to find where this thing equals 0. That's what the x-intercepts are. It's what happens when y equals 0. So when I have an equation equal to 0, the way that I usually want to solve that is by factoring one side and then setting each factor equal to 0. So that's what I'm doing here. I'm factoring, and then I'm going to set each factor equal to 0. So let's look at each of these. I can, oh, goodness, that's not 5. I was like, this is certainly not going to work. How about minus 12? Okay. So I'll factor out a 2x from these first two terms. And then I can factor out a negative 3 from these last two. I notice that when I factored, I got the same thing in both. That's a good sign. I'll go ahead and put an equal 0 sign here just to remind ourselves what we're actually doing. We're solving this equation where it's equal to 0. Put those together. We'll get 2x minus 3 times x plus 4 equals 0. And then we go ahead and set each factor equal to 0. 2x minus 3 equals 0. If you do a little bit of work, that's going to get you that x equals 3 halves. And x plus 4 equals 0. That's going to get me that x equals negative 4. So I now have my x-intercepts. And just for consistency, we can write them as ordered pairs. They're going to be 3 halves, 0, and negative 4, 0 are my two x-intercepts. So we did that. And again, why did I do all this factoring and stuff? Because I was solving where does this equation equal 0. And when you want to solve where something equals 0, factor and set each factor equal to 0 is a good approach. Okay. One more problem on these first two pages. A culture of bacteria begins with a count of 800 and grows exponentially with a continuous rate of r equals 0.0025 per hour. Find the time at which the population will reach a count of 5,000. Please show all steps and don't forget units. So this exam is going to be no calculator. In this problem, this is kind of written for you to use a calculator. So what I'm going to do is I'm going to leave my answer as an exact value. And which you can do without a calculator. You can do all the work I'm about to without a calculator. But if you had a calculator, what you could then do is you could take the gross number that I get, and then you could plug it into a calculator to see what it actually is. So without further ado, we're going to use our model of exponential growth. It's continuous growth. So that means that we're going to use this A0 e to the power of RT. That's going to be our model that we're using, where A0 is the initial amount and R is the rate of growth. So they tell us both those things. This initial amount is 800 bacteria, and then the growth rate is 0.0025. So I wrote A of X over here, and then I wrote T. That's just silly. You should probably be consistent with your variables, so I will try to be so. So we have A of T equals this. So that's a nice first step. Now I want to find when the population will reach a count of 5,000. So we're asking, when will A of T equal 5,000? So what do? I just take this A of T and replace it with 5,000 and then solve for T. I'm looking for the time where this is true. And now I need to solve this equation. It's not the hardest thing in the world, but it's also not the easiest thing in the world. Let's try to get e to the whatever by itself. Go ahead and divide both sides by 800. Those cancel. I have a couple zeros that cancel. And actually, I can also factor out a 2 from these. So I can at least write it as 25 over 4. So I got 25 over 4 equals e to the 0.0025 t. And to cancel out this exponentiation, this e to the power, I want to take the natural log of both sides, because natural log is the inverse of e to the x, or e to the t. So we get natural log of 25 over 4 equals 0.0025 t. And then all I need to do is divide by the 0025 number, and we're golden. So that's what we get. If you really wanted to, so let me write this out. T equals natural log of 25 over 4 over 0.0025. And if you wanted to, you could even write that as natural log of 24 minus natural log of 4 using some log rules. I don't know if I'd expect you to do that, but it's kind of nice. Leaving a decimal in the denominator is usually bad form, but I don't necessarily need you to clean that up. And last but not least, don't forget your units. So what units do we have? T was measured in hours, so this is a number of hours. So there we go. And if you wanted to plug this into a calculator, you would find out exactly how many hours that is, but that's not something I'm going to do here. So there you go. That's how you can do some exponential solves. In the next videos, we'll look at some more detailed solving problems.